Welcome to my channel. Please subscribe. Sensor classes: analog, digital, scalar, vector sensors. Sensors are devices that are used to detect or measure physical or environmental changes and convert them into a readable form for further processing. These devices can be used in various applications like medical, automotive, aerospace, etc. There are different types of sensors available, which can be classified into different categories based on their functionality and output. One such classification is based on the type of output signal, that is, analog or digital. Analog sensors generate an analog output signal that varies continuously with the change in input physical quantity. Examples of analog sensors include temperature sensors, pressure sensors, and humidity sensors. In contrast, digital sensors generate a digital output signal that represents a specific state or level of the physical quantity being measured. Examples of digital sensors include proximity sensors, photodiodes, and accelerometer sensors. Another classification of sensors is based on the nature of the physical quantity they measure. Scalar sensors are used to measure scalar quantities such as temperature, pressure, or humidity. Vector sensors, on the other hand, are used to measure vector quantities such as acceleration, velocity, or displacement. Scalar sensors can be either analog or digital, while vector sensors are primarily digital. In addition to analog and digital sensors, another classification is based on the sensing element used in the sensor. Resistive sensors, capacitive sensors, and inductive sensors are some examples of such sensors. Resistive sensors work based on the change in resistance due to the change in physical quantity, while capacitive sensors work based on the change in capacitance. Inductive sensors, on the other hand, work based on the change in inductance. Each type of sensor has its unique features and advantages, and the choice of sensor depends on the application requirements. Sensor resolution refers to the smallest change in the input physical quantity that the sensor can detect and convert into an output signal. It is an important parameter that affects the accuracy of the measurement. The resolution of a sensor is determined by the number of bits used to represent the output signal. For example, an 8-bit sensor can detect 256 different levels of the physical quantity, while a 16-bit sensor can detect 65,536 different levels. High-resolution sensors offer better accuracy but are also more expensive. Hence, the choice of sensor resolution depends on the accuracy requirements of the application and the available budget. In summary, sensors are devices used to detect or measure physical or environmental changes and convert them into a readable form for further processing. They can be classified into different categories based on their functionality, output signal, and the type of physical quantity they measure. The choice of sensor depends on the application requirements, and factors such as sensor resolution and sensing element should be considered while selecting the sensor for a specific application. Sensor types. Sensors are electronic devices that detect physical or chemical properties of their surroundings and convert them into measurable electrical signals. There are various types of sensors that are used in IoT applications. One type is temperature sensors, which measure the temperature of an object or environment. Another type is light sensors, which detect the presence or absence of light in a particular area. Other sensor types include humidity sensors, gas sensors, motion sensors, pressure sensors, and more. Temperature sensors are used to detect the temperature of a system or environment. They are commonly used in HVAC systems, refrigerators, and food storage units. Light sensors, on the other hand, are used to detect the presence or absence of light in a particular area. They are commonly used in street lights, traffic signals, and security systems. Humidity sensors detect the amount of moisture in the air, and are used in HVAC systems and food storage units. Gas sensors detect the presence of various gases, such as carbon monoxide or methane, and are commonly used in home and industrial safety systems. Motion sensors detect movement in a particular area, and are used in security systems and automatic lighting systems. Pressure sensors detect changes in pressure, and are commonly used in industrial applications. Other types of sensors include proximity sensors, which detect the presence of nearby objects, and touch sensors, which detect touch or pressure. Magnetic sensors detect magnetic fields, and are commonly used in automotive and industrial applications. Accelerometers detect changes in acceleration, and are used in smartphones and other mobile devices to detect orientation and movement. Gyroscopes detect changes in rotational motion, and are used in navigation systems and robotics. Overall, there are many different types of sensors that are used in IoT applications. The type of sensor that is used will depend on the specific application and the properties that need to be measured. By using sensors, IoT devices can gather data about their environment and respond accordingly, making them more intelligent and efficient.